Welcome back to the channel, guys. Hope you are doing extremely well, and this is your very own mascot this side. So, on a positive note, let us start a new series for linked list. I promise you to fulfill all the requirements of linked list, and this video will contain at most around 40 videos starting from linked list from basic scratch. I will assume that you don't know linked list anything, right? You have not understood the concept of linked list, and then you will be able to solve advanced hard questions on lead code for linked list, right? Okay, this is my aim for you to bring out this video, right? So let us start it now. So first, whenever we study a data structure, like linked list is a new data structure to you, right? Linked list is a new data structure to you. What is the need? What is the need? So let us try to understand it. Let us try to understand it. Suppose I say that there is a class of 30 students. There is a class of 30 students, and I want you to make an array of their heights. To make an array of their heights. Let us take their heights in centimeters, right? Okay. So suppose the kids are in secondary, you will use an array, right? You will use an array. You know about that. That array is used to store multiple entries, right? So suppose the array is containing the int answers, right? It is containing integer height of the student. So you will declare something like int array 30 because it is of size 30 equals to, now you will mention all the height. Suppose the height is 160 centimeter, then 166 centimeter, 158 centimeters, so on and so forth, right? And 30 entries, suppose that is ending at 170 centimeter, right? Okay, so these are 30 entries, right? Now the problem arises if I say that I have a new student for you. There is a new admission into a classroom, and I want you to add his or her height into the array which is already defined. Now you will say, as you are a programmer, you know that array size cannot be changed. Array size cannot be changed. Size cannot be changed. Right? So what you will do? You are in a problem now. You will have to solve it programmatically. You will say the one option we have is, because of the new admission, the total strength of the class is 31 students. So what option we have is, I will copy all of these values into another array. I will make a new array of size 31, and I will insert those values, that is 160, 166, 158, up and until all the values, that is 170 centimeter, and at last I will add the new value. Suppose this height is 140 centimeter, right? So I will add 140 centimeter here, right? 140 centimeter here, and now I will free this memory because that is not of a need to me. That is not of a need to me. Okay, you are very happy that you are able to solve a programmatically question and you have a good reputation among the classmates, right? But the teacher is, teacher, how are the teachers are, so now the teacher will say that new student again arises. This is a good financial year for your school. You are getting new students again and again. New student arise. So what is the strength now? 32 students. What you will do, you will make a new array of size 32, right? Add the elements in it, etc, etc, right? Okay, same procedure. Now the problem arises when teacher is not stopping and adding students again and again one by one, that is 33, 34, 35. Now you will get fed up. And you will say, okay, suppose I have 32 students right now, let me make an array of size 50. You will make an array of size 50. Will push all the 32 entries into it. Okay, you will push all the 32 entries. Suppose these are your 32 entries, right? And next remaining 18 entries, you will leave empty. That is, if a new student admits, I will store this location, I will store the values inside this, right? And I will tell the, like, whatever the administration, that 32 entries you will have to check the up till 32 entries, right? That is a possible solution. But the kismet, the luck is not on your side. The students which were newly admitted or the old students decided to leave the school. That is, this student says, I don't want to live here anymore. This student says, I don't want to be in this school anymore, right? They are leaving schools. So okay, that is also acceptable. Suppose this is 166, you will change that to a value that is -1. That is, this place is actually empty. You will say this place is actually empty, no problem, right? This place again 170 centimeter which contains is also empty, right? That can be done. But do you realize that you had already 18 blocks of memory in your system? You are getting two more. that is 20 blocks of memory actually wasted, because once you assign 50 memory location to array, 50 memory location to array, these are actually reserved for this array and these will not be used by any of the data structure or any of the variables, right? These memory addresses are actually belonging to this array of size 50, right? And so I guess you already know about it. These memory address are contiguous blocks, right? That is, if this is the address 1, this will be address of 2, 3, 4, 5, 6, etc, etc, etc. Okay, so these are contiguous array. So do you want to miss that big piece of chunk, big piece of memory size, just to maintain a buffer, just to maintain a buffer? That will not be an like programmatically good time complexity and space complexity problem, right? Because you are using much of the space complexity when it is not needed, right? Because you know the reasons, right? Now, what if I design a data structure? You are a pro programmer and you will design a data structure, right? Design a data structure. Now, a data structure that can come in handy at this time of point is linked list, and that is why we are going to study it. Linked list, as we move on to the advanced data structure, linked list is the easiest one I have ever seen. Linked list is the easiest one I have ever seen, and I will make it more easy for you if you are following this playlist all along. So if you have not subscribed till now, hit the like button, hit the subscribe button, and stay tuned for the more playlist, right? Now, what will happen? I have got the linked list in my hand. I have the linked list in my hand. What do I mean by linked list? So suppose the heights were 160, 166, 170, 180, 140. What will I do? I will say that array was storing the memory in contiguous blocks. I say that I don't need contiguous blocks, I just need to maintain the data. That is very true. So I will say I will store 160 at one memory location, 166 at another memory location, 170 at another memory location, 180 at another memory location, 140 at another memory location, right? These are different memory location. They might not be contiguous, they might be contiguous. That is not your problem. You are storing, suppose this is memory address 1, A1, A2, A3, A4, A5, right? Now, you want to store them, okay. Now, 166 is actually coming after 160. 166 is actually coming after 160. So what you will do, you will say, let me make a connection between them. Let me make a connection between them. That is, 160 will point a node, something like this. That is, 160 will be pointing me that, hey, this is my next. That 160 contains 166. Again, 166 says, this is my next. And 170 says, this is my next. That is, after 170, 180 will occur. The node of 180 will occur. And similarly, 180 will say, this is my next. Now, because 140 does not have a next, that is 140 is the last entry. So 140 will say my next is null. That is, at this point of time, I don't have anything next to me, right? I am the last one. I am the last one. This is a linked list. See, are you able to understand what is the use of linked list and how do we design a linked list? This is a linked list. That is, suppose this is a node, right? This is a node. This node contains data point, that is data point is 160, 166, 170, 180, 140, etc. And along with that, it contains the next pointer. Next pointer. What do I mean by next point? Next pointer to node. Next pointer to next node. To be specific, next pointer to next node. That is this pointer, this brown line will contain the next pointer. That is address of this node. Let me mark, I am saying address of node. Address of node. That will be of use when I will be teaching forward. Address of node. Now, the linked list data structure is actually very clear to us that what is it in the visualization. How does it look like in the visualization? Now let us move towards how to implement it, because if you're not able to do something on the program, then it is not worth studying, right? It is not worth studying, right? How to implement it. Now, these are the two things we have to take care of. These are the two things we have to take care of. Now, do you realize that this data is of type int? In the given case, this is the type of integer. Okay, so I will have to make something sort of integer to store this int. Now this pointer, if I say this is of node, this, let us name this pointer as node. So I will say this pointer is actually pointing pointer towards node, pointer towards node, and pointer. I'm being more specific on the word pointer, pointer, right? So if you have a clear understanding of pointer, that is very well for you. Otherwise, I am going to teach you the one that is needed for linked list. right? So how does the work of pointer works? So pointer, suppose I say int a is equals to 5. Int a is equals to 5. What does this line state? This line states that this line will make a block in the heap memory assigned with the value a, and this memory block will be known by the name of a. This memory block will have the name of a, right? It will have some memory address, but I am not caring about that right now. But somehow a programming expert, a programming curious guy rises up and says, I want to know this memory address. I want to know this memory address. So this memory address can be accessed using and percentile, right? This memory address can be accessed using and percentile. This will give me this memory address, right? Now where I will store it? Where I will store it? Suppose I store it in B. Now what is the data type of B? What is the data type of B? So as you can see, my B is actually pointing, right? I am mentioning pointing again. Actually pointing towards this memory address. That is, it is acting like a pointer. So I will say int star pointer, because B cannot store its memory address. Memory address is actually hexadecimal. B cannot store. Int B equals to and a is not programmatically correct. That is not possible, right? So I will have to make a pointer. This pointer will store my memory address. Star will be my pointer. Now if I will say C out and a, or I can say C out only B, these two values will give me this memory address. These two values will give me this memory address, right? This memory address. Now going back to the linked list, our need was to store data, our need was to store pointer. Now you realize that node contains both these value at once, right? So I need to store an integer, I need to store a pointer. What is the pointer pointing at? It is pointing at a node. It is pointing at a node. I got my answer. Because I want to use two data structures in one frame, I have to use a struct. So struct are nothing but a user defined data type. So I will use a struct. Let us name it as node only. So I got a struct node. Now integer pointer, right? So I will make a data type int data, which will hold my integer value. Now pointer, as discussed, this pointer has to be declared of star type, and this is declaring a pointer of node. So instead of int, it will be node star. So I will say node star. And what is this pointer pointing at? It is pointing at the next node. So let us save it by the name of next only. Int data node star next. That will be my declaration, right? Now how will I declare a node? That is, how will I make a node of 160? I have got the struct node with me. How will I make the node of 160, right? So I'm quite sure that you are familiar with the word of constructor. So that means whenever a new node will be constructed, the constructor will be called automatically. Suppose I send data 1 and next one. Oh, next one. Right? So what will happen here is I can say data equals to data 1. That is, whenever I make a new node, assign this data 1 to data and next to this next one. Next equals to next one. Right? This is just a constructor. I am sure that you know about it. Whenever I will call the struct node, whenever I will make a new node, this constructor will be called automatically. And this data 1, which I will send as an argument, will be assigned to the data, that is to the node, and this next one will be assigned to the next, that is to the next of the node, right? Now how will I make? Suppose I have to make a node which will contain my value of 160, and suppose I will have to create a node of 166, and I will have to point this. So before pointing this next pointer, I should have been existing with this, right? Because next will be pointing to this memory address, and 160 is the original parent of next, right? So what will I say? I will make a node of 160. So I will use a new keyword. What does new keyword do? New keyword will assign you a new memory address for this node. So I will say, let us name this node as A, let us name this node as B, let us name this node as A, let us name this node as B. So I will say node star. I will say node star. I will not say node, I will say node star. Why? Because this node star, let us say A, is pointing at the memory address of this, struct node, right? That is why only I can get the value of node. Node star A equals to new node. New will give me the new memory address, right? New will give me the memory address in the heap. New node. Now what will I assign? I want to data of 160, so I will send an argument 160 here, 160. Next, let us say next is null right now. Next is null. I will change it afterwards. Next is null, right? Next is null. Similarly, I will say node star b equals to new node data is contained is 166, and let us make it as null pointer right now. Let us make it as null pointer. Now I want to make this connection. I have made this node. I have made this node. The remaining thing is this null, this next connection. So I will say a is next has to be b. So a next equals to b, and you will develop this connection, right? This connection, and that is why this will be known as your linked list. This will be known as your linked list. So for the case of this one, let us try to make the linked list of this. Let us try to make the linked list of this given parameters, right? Here we are. Let us name it as a b c d e. So I will make node star a equals to, I will make a new node. I will send the value of 160 and null pointer here. Similarly, for B, I will write the whole line same. Instead of 160, I will say 166 null pointer. For C, I will say 170. For D, I will say 180. For E, I will say 140. Right? Now, I will have to make connection. So you can see B is the next of A. So I will say after this code, after this line, 5 lines of code, I will say A next equals to B. Okay. B next is equals to C. C next is equals to D, and D next is equals to E. Now what about E next? So E next is already null, and E next has already been assigned as null, right? E next has already been assigned as null. So this is how you get a linked list. This is how you get the linked list. Now moving towards the nomenclature, the first node of the linked list, the first node of the linked list is known as head. And whenever you will face a question of linked list, you will be given only the head. Why only the head? Because if you have the head, you can actually traverse all the linked list. From heads next, you can go to this. From this next, you can go to this. From this next, you will go to this. From 180s next, you will go to 140. From 180s next, you can use the end, that is null, right? So you will always given head. So this linked list is starting from A. So my A is head right now. Similar to head, I will have a tail, which is the last node, right? Similar to head, which we will have a tail. And this is the only nomenclature you want to know about linked list, believe me, right? So these are the cases of the linked list. This is the implementation of the linked list. Now let us try to take it on the VS Code and let us try to run it. So alright guys, here we are. So you can see I've made a basic template of the C++ code. Now first I will define the struct node, right? Because I want a node of this type. Struct node, let me change the spelling, correct the spelling, right? I will take an integer data and I will be storing a node star, that is the same type of node. Let us name it as next. My constructor will be named something like int data1, let's say, and node star next one. Inside the constructor, I will assign data1 and next equals to next one, right? So this is my struct. I will just end it with the semicolon, and now I'm ready to go with the linked list. Suppose the array I want to make is, suppose is of length 5. What is the array? 160, 166, what was the value? 170, 180, 140 was the value. Now to add this, what will I do? I will make a linked list. So how will I make a linked list? First I will create all the nodes. Suppose node star A equals to 160. So I will say new node. Now what is the value I want? I want 160 as my value and null pointer as my next value, right? Similarly, I will copy it down for all other values. So, right, I will assign B to it, I will assign C to it, D here, E here, right? And I will assign the values of 166 first, then 170, followed by 180, and then at last 140, and this will be ended by semicolon, and then that will get resolved, right? Okay, so I've got all the nodes. The only thing left is to make the connection. So that is A's next is equals to B. A's next will become B, and I will copy it down for the rest of it. That is, I have to make 4 connections, right? B to C, C to D, D to E. B to C, C to D, D to E. So B to C, C to D, and similarly D to E. That will be my last connection, right? D to E, right? This will be my last connection. Now, you wanted to study linked list because you wanted to add a value here. This is not possible to add a value in the array of a predefined size. I can add the value here. How will I do it? I will make a new node. I will make a new node, node star, let us say f equals to new node, and let us assign this value as 130. Let us assign this value as null pointer, right? Okay, this will make you a new node, right? I can simply say that e is next, that is the last next, is equals to f. How will I access it? So I can say C out, what is e? E is next, e is next data, that is e is next will give me f, and f data will give me 130. Let us try to run it, hope it will run fine. So in the terminal, you can see 130 is getting printed up. So you can see the problem of adding the values without disturbing, without copying the data of the arrays again and again. I can simply use linked list. I can simply use linked list, right? Okay. So this was all for this video, and we'll meet again in the next lecture where we'll be studying about the insertion, deletion, and many other operations on the linked list. So stay tuned, and if you have not subscribed till now, please do subscribe to my channel. Okay. Thank you for watching. Have a nice day.